Welcome to our class in regression analysis, specifically linear regression. Linear regression is mainly about relationships that exist. Relationships exist between two variables, we call that linear regression. More than two variables, we call that multiple regression. And so relationships that may exist between what are called dependent and independent variables. A dependent variable y depends on x, which is an independent variable. So the typified relationships that we are able to see here can be summarized into four. We have a positive relationship, we have negative relationship, and we have no relationship at all. Positive relationship is upsloping. Negative relationship is downsloping. And these dots that you are seeing here make up what is called a scatter diagram. These dots, if they're close to each other, the relationship is close or strong. If they are further away from each other, the relationship is weak. So this is the negative but strong, negative but weak. And here we have no relationship at all. R stands for what is called the coefficient of correlation. Coefficient of correlation, it gives you a picture to say this is a positive relationship. If your answer is positive, this is a positive relationship. If your slope is downward sloping, it's a negative relationship. R squared, on the other hand, stands for what is called the coefficient of determination. If your R squared is more than 50, it is a strong relationship. Between 30 and 50, it is a moderate relationship. Below 30%, it is a weak relationship. So relationships are defined by what we call the prediction equation, which is given by y is equal to a plus bx, where a is the y-intercept, the cutting point, and b is the slope, which is the gradient. So regression is used for the following. Number one, to ascertain the strength of the relationship. The strength of the relationship. So the strength of the relationship is typified by R squared. We also have, if R squared is 0.9, it means 90%. Means 90% of y is influenced by x. If our R squared is 0.4, in a percentage, this means 40% of the variation in y is as a result of the variation in x. If your R squared is 0, it means there is no relationship at all. So relationships examples could be typified, for instance, sales against advertising, where sales is the dependent variable and y and x is the independent variable, which is the advertisements. Age against BP, length of experience against output. Other relationships that can be there between demand and supply. So it is also able to tell you the type of relationship using R. R stands for the correlation coefficient. It simply tells you whether the relationship is positive or whether the relationship is negative. So this is a positive relationship when your slope is positive, and this is a negative relationship when your slope is negative. So y is equal to a plus bx. Y is equal to a plus bx. This is the prediction equation. This is what we call the regression equation. We're able to predict future cells or the probable BP or the age using a regression equation. So the formulas we're going to make use of: y plus bx, y is equal to a plus bx, and r is equal to sxxy, ssxx, ssyy. You multiply xy, xx times yy in the square root. Answer we get when you square it is called our r squared. So what is summation of x, y? Sum of squares x, y, sum of square x, x, and sum of square y, y. It's simply sum of square x, x, the summation of x to the power 2, x squared, minus summation of x to the power 2 over n. Y, y, we have y's throughout. Summation of y to the power 2 over summation of y in brackets the power 2 over n. Y is throughout. xy, here we have xy minus summation of x times summation of y over n. Then how do we find the a, which is the y-intercept? You need to take note of these formulas. So it is summation of y over n minus b summation of x over n. So our sum of square total is same as summation of syy. It's the same thing. So I'll get back to these ones firstly. Now let's just learn how to do the prediction equation. So we're given the values of x and y: 1, 2, 3, 4, 5, 1, 1, 2, 2, 4. So in this table, we are now going to expand this table as follows. So firstly, we've been taught to draw a scatter diagram, x, y. So x is 1, 1, so you put 1, 1 here. Here we have 2, 1, so here 2.
Hey, Collins.
Hello?
Can we just look at the formulas again? I'm trying to see for solution for y. I've noticed something. Can they scroll up? Up where the formulas are. Yeah, so the solution for the formulas down where there's the where y is equals to a plus bx, r is equals to solution of xy over solution square root solution of xx multiplied by slightly down. Yeah.
Okay, so our r is sum of square xy over sum of square xx times yy.
Sorry, I dropped off.
Okay.
Okay, I've seen where okay, there's xy and then there's also yy.
Yes.
Okay, all right. So the one that has y squared, that is the summation of y squared minus brackets y squared is for solution of yy.
Yes,
right?
yy, yeah. So their y is throughout only. X, their x is throughout only. Except that this is x the power 2, x squared the power 2. Then where there is xy, we have xy here and xy here. So this is x and y over n.
Okay, then there's a part where a is equals to summation of y over n, then b is equals to summation of x over n, right?
No, this is the whole formula for a. Summation of y over n minus b summation of x over n.
Ah, okay, all right, perfect. Okay, sure. Can go ahead.
So now we go to this example here. We have been asked to draw the scatter diagram, to write down the prediction equation, to ascertain y when x is 10, to draw a NOVA table and the relationship at 5%. So now we have these values here, x, y. So 1, 1 is here, 2, 1 is here, and 3, 2. So 3, 2, and 4, 2, 4, 2, and finally 5, 4, 5, 4. Okay. All right. So this is what is called the scatter diagram. This is our y, and this is our x. Then we're going to expand the table. 2, 1, 2, 3, 4, 5. Then here we have 1, 1, 2, 2, 4. So xy, we're multiplying this times that is 1. 2 times 1 is 2. 3 times 2 is 6. So we're multiplying each of these ones here to get xy. To get y squared, x squared, 1 times 1 is 1. 2 times 2, 4, 9, 16, 25. So this is what we have here. Then this column, we're also squaring them. We have 1, 1, 4, 4, 16. So you see how those computations are done? Are we together so far? Have you seen how these computations are done? And we total them up. So when we total them up, those are the figures we are getting. So now what is key and important now is to calculating the sum of squares. The sum of squares. So sum of square xx is summation of x squared minus summation of x to the power 2 over n. So here we have 55 minus 15 to the power 2 over 5. We get a 10. Summation of y squared minus summation of y to the power 2 over n. So it's 26 minus 10 squared over our n, which is 5. N is the number of pairs, so 5. So we got 6 there. Then summation of xy, we have summation of xy, summation of x and summation of y over n. So we get this, and our final answer is 7. So these are very important and our preliminaries before we go any further, because they'll help us calculate the remaining answers. So now, after finding the sum of squares, we can find our b, our slope. So to find our slope, we have summation of xy over summation of xx. So this is 7 over 10, since we found summation of xx and summation of xy. So summation of xy is 7 here. Summation of xx is 10. So when you divide 10 into 7, 0.5, 0.7. Is that clear? So we're just using the answers that we have here. Then when we go to calculating our R, our R is summation of xy over summation of xx times yy. So since we have our xy at 7, we put it 7 there. Xx, yy, so 10 times 6. So when you divide root 60 into 7, we get 0.903. So this is our R. Then when we square it, we get our R squared. Remember, R stands for coefficient of correlation. R squared stands for coefficient of determination. So we're simply squaring this answer here. We get 0.816. So remember, to interpret this here, 0.903 to the power 2, 0.816, it means 81.6% of y is influenced by x. Then the formula for a was summation of y over n minus b summation of x over n. So summation of y over n, the answer b we found here, we are supposed to use it in here. Then our final answer will be negative 0.1. We haven't answered any of the questions. So the question is number 1, calculate the regression equation. So since our a was negative 0.1, we put where there's a, negative 0.1. Plus our b is 0.7. So where there's b, you put 0.7. And you put the x there. That is what we call the regression equation. Then predict y if x is 10. So where there's x, we simply put a 10. What are you getting? What are you getting here?
6.9.
6.9. Correct. So this is our prediction. If x is equal to 10, what is our y? All right. Then we go to our ANOVA table. Now, before I go to the ANOVA table, I just want to do a quick recap in case any of those that have joined us are left behind. Just a quick recap.
Thanks, I actually needed it. Thank you.
All right. So we are being asked to do a regression. A regression, like we said, is mainly used for 2 variables or more. If there are 2, we call it linear regression. If there are more, we call it multiple regression. So we're actually answering this question here. So quickly, we just mentioned to say, so consider the following pairs of measurement. We have x and y. So we've been asked to construct what we call a scatter diagram. So scatter diagram is simply identifying where they are falling. 1, 1. So 1 against 1, this is where the dot is. 2, 1, this is where the dot is. 3, 2, 4, 2, so 4 against 2, and finally 5, 4, so 5 against 4. This is where the scatter diagram ends. So what does this plot suggest? The relationship is what? Positive, it's upsloping. So the scatter diagram can tell you that there's a strong linear relationship between x and y, which is a positive slope. The dots are close to each other. Then you've been asked to fit the regression line and predict when x is equal to 2. So you need to come up with this table. So that table that I was talking about, where you have x values and y values. So this table, where you put them or rearrange them as follows. So x values are here, the y values are here. xy, when you multiply this by that, this by that, this by that, this by that, all right? So when you put these values here, x squared, when you're squaring each individual here, these are the values. Y squared, when you're squaring these values here, and the totals are key. So we have 15, 10, 35, 55, and 26. So these are the values. So how do we find the sum of xx? So sum of xx is simply found by the following formula: summation of xx, summation of x squared over summation of x to the power 2 over n. So 55 minus 15 squared over 5, you get 10. Yy is 6, xy is 7. I'll share the video afterwards in case you did not get it. So these are formulas that you need to master. You need to know these formulas. So after finding our xx and yy, which are as shown here, so our xx is 10, our xy is 7, and our yy was 6. So to find our slope b is simply xy over xx, so 7 over 10, which was 0.7. And to find our a, it's simply the mean of y minus b mean of x. So our mean of y is simply summation of y over n. So our summation of y over n, when we go here, 10 over 5, which is 2, then b summation of x over n, so 15 over 5, which is 3. So in this equation, our mean of x is 3, our mean of y is 2. So the formula for a is simply mean of y minus b mean of x. So where there's mean of y, we put 2. Mean of x, we put 3. Then our b as calculated here is 0.7. So when you calculate this, our final answer of a is negative 0.1. So using the regression equation, where there is a, we put negative 0.1. Where there is b, we put 0.7. So this is just the equation. Then we are asked to predict for y if x is 2. So where there's x, we put 2. So we get our answer as 1.3. At this point, are there any questions?
No question from me.
Okay, so I'll proceed. So now we've been asked to come up with what we call the ANOVA table. Now, before you understand the ANOVA table it has a formula. So this is how we draw the ANOVA table. So the ANOVA table is drawn like this. So this is how the ANOVA table is drawn. Sum of square regression, sum of square error, sum of square total. The degree of freedom for the regression is 1. Degree of freedom for the error is n minus 2. The degree of freedom for the total is n minus 1. And the degree of and the mean square regression, MSR, mean square error, is MSE. And the F calculated is found as follows. So this I'll explain more at a later time. But one thing you need to understand is that the sum of square total is the same as sum of square YY. And sum of square SSR has this formula given as follows: summation of xy to the power 2 over xx. So once you find these two, the rest can be found. So SSR is summation of xy to the power 2 over xx. You put your answer there. Sum of square total is the same as sum of square yy. Then the difference is your error. So when you go to our computation here, you discover that our sum of square total was 6. Then sum of square regression is xx over xy squared over xx. So when you square this one, 7 squared is 49 divided by 10 is 4.9. So I'll explain this at a later time. For now, I just want to concentrate on these parts that are to do with regression. So how do we find our error? We already found our error as 0.903. So our error was 0.903. So this means that is a positive relationship, which is even strong. When we square this answer, we get our error squared, which is our coefficient of determination. So when we square this answer, we get 81.667. To interpret that, it says that the variation, 81.667 of the variation in y is explained by the variation in x. So really, your homework will simply be to do question number 2 here. Just leave out part C. You can do the rest of them because I've explained. Just leave out part C, which I'll do in the evening. You leave out the rest, do the rest and leave out part C. So you can also finish up this because I've given you the notes on the group. These notes I've just explained to you, I have given you on the group. So unless there are any questions.